Refer to page 47. Page 47, chapter. In your module is chapter 2, but if according to our RPP is chapter 4, multiple integral. So this chapter you will deal with a lot of integration. So no more differentiation, but integration. So you will deal with double integrals. Okay, double integrals. Double integral means you will have two symbols of integrals, and behind will be terminate with dA. So for this double integral, you will use it to find the area of a region. Okay, you will use it to find the volume of a structure. Okay, you have learned how to draw a 3D structure, right? So you will have to use this double integral to find its volume and also to find the surface area. Okay, surface area of the 3D structure that you have constructed. So this dA actually represents area. Okay, area, and you have to deal with two types of coordinate system that you have learned before. That is Cartesian, okay, and also polar. Okay, next one will be about the triple integrals. So for triple integrals, you will have three symbols, integration symbol, and here normally we write dV. The V actually represents the volume. So we will use these triple integrals to find the volume. Okay, so this means that you can use double integrals or triple integrals to find the volume of a 3D structure. Okay? And in these triple integrals, you are going to deal with three types of coordinate systems. Okay, that is Cartesian, okay, cylindrical, and the last one is spherical. So all these coordinate systems you have learned in the first chapter, right? So you are going to use the parameter in the coordinate system in order to solve for the volume, to solve for the area or surface area. So before we go in deep into how to find all these things, I just want to refresh back about the law of integration. Okay, so last week I asked you to prepare a formula sheet for the differentiation, right? So actually when you are searching for the rules of differentiation, sometimes the rules of the integration will be included as well. Okay, if you didn't find the rules for the integrations, okay, please find it because you will use it extensively in this chapter. Okay, so let's go back to the basic of integration. Okay, basic of integration. We go to the most basic one. How to perform these integrations? Yes, x6 over 6 means the 5 you plus 1 and the 6 you divide it. Okay, this is the most basic one. Okay, after that, what will happen if it is sine dx? You will get cos, right? Yes, negative cos x. Different a bit compared to the differentiation. And for cos, you will get positive sine x. Okay, next we upgrade a bit. How about what you will do? Macam mana? So you remain this 2x plus 1, and for the 3 you plus 1 to become 4. Okay, so you put your 4 here, and after that you have to look for the parameter inside the bracket. If you are going to if you are going to integrate with respect to x, then you look at this one. Okay, so you will have 2 here. Okay, you will have 2 here. Am I right? Okay, so this one will be your answer. Okay, this one will be your answer. Next, is there any other interesting one? Okay, next, what will happen if you integrate 2x dx? What will be your answer? Exponential 2x and then divide 2. For differentiation, you multiply 2, right? So for integration, you have to divide 2, okay? Any more special one? Okay. How about this one? 1 over x dx. What will be your answer? Log x. Okay, this is a basic one. So try to search for your own the integration law. Okay, now we are going to move to the basic calculation that involve double integrals. Okay, this is single integrals. Now we move on to double integrals as in your module. Okay, you can look at example 2.1, page 49. Page 49. Example 2.1. Okay, can refer to question A. Okay, so you have one, 3, 0 pi over 4, and then 2x, second, y, dy, dx. Okay, so when you have two integration symbol behind, you will dot up with another dy dx. You will also have two terms here. Okay, if for single integration, you see one match with one. Am I right? This one match with this one, and the outside one match with dx. When double, you will have double here. And don't miss the term here. Right? This is how we define the double integrals. So let's look at how we are going to solve this one. So we solve it one by one. We solve the term inside dulu. Okay, this one. So we zoom into parameter inside. Okay. By looking at this parameter, we know we are going to integrate with respect to y. So when we look at what is inside here, this is 2x. So in this case, the x we have to assume it as a constant, just like what you have performed in differentiation, constant. So when constant, we move it outside. Okay? We don't want it to mix into the integrations. So I rewrite the question to be like this. Okay? Constant, you move it outside. So now you are going to perform integration for this second square y. So you have to refer to your formula sheet. Okay, so refer to your formula sheet. So this one you will get answer tangent. Am I right? Okay, so for this one, you will get your answer equals to tangent. Okay? So this one will become tangent y. Okay? And then you put your interval outside. So what you are going to do next is you replace the value of the interval into the equation, into the formula. And this is minus tangent 0. Okay, so you can press your calculator. What will be the answer? So before you press in your calculator, what you have to do? Yes, very good. You have to check whether your calculator is in mode degree or radian. If it is in degree, you have to change it to radian. Okay? You have to change it to radians. So you press calculator. Okay, you will get your answer for this part is equals to 1. So at the end, you have 2x. Okay, can you get 1 here? Yes, huh? Okay, so this 2x, you haven't finished your question yet. This 2x is the answer after you perform the integration for the inner part. Okay, you have outer part lagi. So, you have to replace this 2x in the outer part. And this time, you have to differentiate with respect, integrate with respect to x. And the interval will be from 1 to 3. Okay, so I think this one will be easy for you. Am I right? So it will become 2x squared over 2 and 3, 1. So this one you can cancel. Okay, and then 3 squared minus 1 squared. You will get 8. Okay, so this one will be your answer. Okay, by the way, class, do you know you can use your calculator to perform integration? Do you know how to use it? Okay, for modern calculator, after you press the integration, you will see this symbol, right? And here there is some sort like a box. Am I right? And for you to fill up the value. But if you are using this version, okay, you will see something like this only. Okay? So what you have to do? So for this question, for example, you fill up the 2x here, and then the interval 3 is here, 1 is here. Okay? This is very easy, right? Okay, you can try to press. As for this calculator, okay, how you should key in your parameter? First of all, you key in 2x. After that, you press comma. Yeah? This is for the older version of calculator. Okay, after that you insert your interval 1. Then after that, comma again. And then 3. Okay, and then you press equals to. Can you? Okay, this is it means that without performing the steps in the exam, you can straight away press the calculator and give me your answer equals to 8. That is fine, and that will be also faster. Okay, this is actually a simple one. You can press complicated inside your calculator, then they will straight away give you an answer. Okay, so may I know who is having problem pressing your calculator? For this one also okay, right? Huh? Any problem? Okay, that's why I do this equal to common. Okay, any problem? You can do it, yeah? What's that? Somebody said you see? You have to set like this. Okay, no problem, everyone. You can use your calculator. Okay? So this is how we perform the integration using calculator. Okay, next. I want you to try another question, which is in exercise 2A, page 50. Okay? Please refer to page 50, exercise 2A. Let's try one more question. That is question 1A. So are you ready for these questions? So you might ask whether our calculator can directly give me answer for these questions. The answer is no. But you can get the answer directly if you key into the mathematical software inside the computer. You have to learn Maple, right? So when you key in this one in Maple, they will straight away give you answer. Okay, but in the exam you don't have Maple. You only have a calculator. So let's see how to solve this one. So as usual, you have to solve the inner integral first. Okay, inner integral. So I rewrite it here. Okay, so this is your inner integrals. And you have to integrate with respect to y. So you have to bear in your mind, x here will be constant. So you move your x out. Can you move this thing out? No. Okay? So, what you should do next? So now, for this case, this question, you have to use one of the rules of integration. That is the substitution. Okay? Substitution, You have to use rule substitution. By the way, for this one, can you press calculator directly? Can you press calculator? No, because there is one variable, x, and we have to assume it as a constant here. We don't know its value. That's why we cannot key in the calculator. But if we don't have this x, you can key in calculator and get your answer directly. You get what I mean? In this case, you cannot press calculator directly. But if there is no x, you can press calculator. You get what I mean? So let's see how to solve this one. Substitution. So substitution, it means we have to replace the variable y with another parameter u. So in this case, I assume my u to be y squared. So this y squared, I will replace it. I will substitute it with u. Okay? And then here I have to perform a simple differentiation in order to find the du, dy. Later I will show you why I need to perform the differentiations. So when I perform the differentiation, I will get 2y. Am I right? Okay, so when I look back into my integrals, I rewrite it y exponential. Here is x, right? Y squared, I replace it with u. And here I have another dy. Am I right? So this dy, you have to replace it with du over 2y. Can you see it? This dy I move up and this 2y I move down. So become like this. Okay? So now my dy here, I cannot put dy anymore because I want to transform it to a variable, a new variable that contains u or du. So this one will become, my dy will become du over 2y. Okay, so when you choose this substitution technique, normally you will find that this thing can be cancelled out. Okay, can be cancelled out. So when you check again your new formula, your new integrals, it will become a simple one. Am I right? Okay, so you can perform the integration easily and your answer will be equals to exponential xu divide x. Jangan confuse because this one you want to integrate with respect to u. That's why x is your constant. So your constant you have to keep it here. You clear? Yeah. Huh? Oh yeah. I missed out the 2. Yes, thank you. Okay, here. Okay, don't miss out anything like me. Okay, so it will become like this. Nampak tak? Okay, so now after you have complete the integration, you replace back your u with y square over, okay, and then over 2x. Boleh ikut tak? Boleh ikut? So this is one of the integration technique. That's why you have to refresh back. So when you perform, after you perform the integration, here you have integrals actually, and you have interval. Okay, so you have to replace your interval into it. Exponential x u square y square over 2x, and your y you have to replace it with 1 and 0. And where this x come from? Here. Okay, so the result of the integration will be this one. That's why I put it here. Okay, that's why I put it here. 1 and 0 is the interval, integration interval. So you continue to do it. So this x you can cancel it. Okay, it will become 1 over 2 exponential x. You replace your y with 1. Don't confuse jangan replace your x with 1. Different story. Okay, and then you replace your y with 0, and this one will become 1. Okay, so this now you will have 1 over 2 exponential x minus 1. Can you follow? Yes, Okay, next we have to move on to the integral, outside integral. Outside integral mana? Ingat tak? Just now I'm talking about the inner integrals. Now you have to put the answer that we got just now into this part and perform the second integral with respect to dx. Okay, so this is the second integrals. Okay, and then you put your 1 over 2 exponential x minus 1 and then dx here. Okay, so can you use calculator now? Can you try? Can you try use your calculator and see what answer you can get? The answer in your module is equals to 0.153. Can you get this thing based on this one in your from your calculator? Yes. Okay? So this one will be your answer. Okay, so this made the integration process much more simple, and the percentage that you got correct answer is higher. Am I right? But make sure you press the correct value. Okay, double check it. Okay, you get some. Any problem? Okay. Calculator, you have to press 0, then only long 2. Bukan long 2, but then 0. You get what I mean? That's right. Okay? You kan ada letak comma kan? Betul. Lepas comma, you put 0 first instead of long 2. Okay? Otherwise, you will get negative answer. Okay? So I assume, yeah. Cannot. On how you perform the double integration. Now we are going to use it. Okay, use it. Okay, so it means that in the question just now, I give you the value of the interval. Am I right? Okay, this value I give you. Okay, in the next session, you are going to find out this value yourself and then perform the calculation. Okay, so we move on to the. We move on to the question. Okay, I type the question here. Please copy this question. I actually modified a bit. Now you are going to use the double integrals to find the area of region. Area of region. Okay? Area of region. So the formula that you have to use is you have double integrals, and what is inside is 1, and behind you have the A. Okay, this is the formula. Okay, let's see how we do it. Then I label it. to be y. I label it to be x. Here the intersection point is 2. Here will be 2 as well. Okay? And I give you the equation of this line to be x plus y equals to 2. Okay? Now you have a region. This will be your region. We have to use the double integrals to find the area of this region. Okay? You clear your task? So normally what you will do if I ask you to find the area of this triangle, what you will do? Pakai teknik yang you belajar bila form 5 ke? What you will do to find the area of a triangle? 1/2. Okay? Base. Yes. And also height. Am I right? So the answer for this case will be 1/2 multiply with 2 and 2. So your answer will be, okay, let's prove this answer by using the area of region, this formula. Okay? Okay, so I redraw again the triangle. There are two techniques, Two techniques in these double integrals in order to calculate the area. The first one is vertical strip technique. Okay? The second one is horizontal strip technique. Okay, I will explain one by one. Okay? So let's look at the first one, vertical strip. So I redraw again my region. So for vertical strip technique, you have to construct a vertical strip inside your region. Can you follow? Okay, I'm talking about the vertical strip technique in order to find the area of this region. Okay, first you have to construct the vertical strip. Ini adalah vertical strip. You have two vertical line. Am I right? So if I move this line to the minimum, where can it be? Jika saya gerakkan dia pergi ke tempat yang paling kecil, pergi ke the minimum point of x, it will be 0. Betul tak? You gerakkan dia macam satu garis, you boleh gerakkan dia. Okay? If you move this line to the minimum, you will have your x equals to 0. If you move this to maximum, 2, right? You cannot move exceed 2, or you cannot move exceed 0, because this is the region you want to find its area. So the x will be from 0 to 2. You agree? I repeat, This is the vertical strip. So this vertical line, if I move it to the minimum point, so you will move it until this point, am I right? And at this point, you will have your x value equals to 0. So next, if I move this vertical line to the maximum, you will have your x value equals to 2. Correct? Okay. Next, you have to assume yourself inside this vertical strip, di dalam dia. What will happen if you look down? What you will see? You will see this line, am I right? So what is this line? This line has value of y equals to, do you agree? Yes, If you look up, what you will see? You will see this line. Do you agree? What is the equation of this line? x plus y equals to 2. Just now I say my y, when I look down, it is 0, right? If I look up, I will find my y will be equals to 2 minus x. Okay? I repeat again, for the y, you assume yourself inside the vertical strip. When you look down, okay, when you look down, you see this base. Okay? And this base, it has value y of 0. That's why I write 0 here. Next, I refer up. I tengok atas. I nampak bumbung. Bumbung itu ada kecondongan. And that kecondongan is depend on this equation, the line's equation. Okay, since here I want y, I have to keep my y on the left hand side, and the x, I move it to the right hand side. That's why when I refer up, I can see the equation of the line is 2 minus x. No problem? No problem, huh? Okay, now we are going to construct our double integrals formula. Remember what is inside? 1. Okay? So when you compare these two terms, x and y, x, you find it to have value. Am I right? Value. 0, 2. But this one, y, it has variable. Okay? So whatever you have, if you found that it is a constant, you pull it outside. The others, you pull it inside. Here remain 1. Just now, what is here? dA, am I right? So this dA, you have to change it according to your parameter here. So this is actually interval for y. So you have to put dy here. And this is interval for the x. You have to put dx here. They are matching each other. You clear? Clear tak? Ini equation to calculate the area of the region. I repeat again. After you define the interval, you put the one that has constant value. Tak ada variable, tak ada x kuasa 2, y ke apa, tak ada. Value, your value, you have to put it outside. And the remaining, you put it inside. Okay, so 0, 2 minus x is referred to the interval for y. That's why your y, you must put it here. You cannot put it outside. Different things, dy here. And 0 to 2 refers to the interval for x. So your x, you have to put it outside. You clear? Okay. Next, you can solve. Can you try to solve this one and see whether you get your answer equals to 2? Can you try? The area of a region. Of course you will say, ini senang saja, kenapa saya nak pakai teknik yang macam ni complicated kan? Saya 1/2 darab base darab height terus dapat jawapan. In real case, you might deal with different types of region. Okay, yang pelik-pelik dia punya bentuk. So you have to use this technique in order to find its area. Okay? So I have explained about the vertical strip technique. Okay, remember just now I mentioned there are two techniques, right? The second technique is horizontal. So let's move on to horizontal strip technique. Okay? Horizontal, Horizontal strip technique. So for this horizontal strip, again I draw my region. So this is 2 and this is 2. Okay. Can you guess what I should do for this horizontal strip? Yes, you draw a horizontal strip this round. Okay, horizontal strip macam ni. Okay, so now you have to imagine this line, tengok line ini, line horizontal ini, what will happen if I move up to the maximum? What will be the value? Equals to y will be equals to 2. Am I right? If I move to minimum, sorry, this one is always start from minimum until maximum. Maximum it will be up to 2, right? Minimum it will be 0. Okay? And now for the x, what will happen if you refer to the left side? What you will see? 0, right? Your x will be 0. And what happened to your y? What you will get? What is the equation of this line? X plus y equals to 2. So what should be here? What should be here? Yes, good. 2 minus y. Okay? So since here you want the x, right? So you keep your x here. Y you move to the right side. Okay, that's why 2 minus y I put it here. You clear? Okay? Next, please fill up this thing for me. Can you fill up? What should be here? Yes, good. Then here will be 0, 2 minus y. So what will be the next thing here? D? Who says dx? Okay, who says dy? Who don't know? Okay, it's okay, no problem. Okay, look, 0, 2 minus y, right? Where this thing come from? X, right? So x is here. Okay, so dia macam matching tau. Dia macam husband and wife matching. Okay, 0, 2 minus y, dx is here. So 0, 2, nampak tak belakang? 0, 2 is dy. So it should be dy. They matching. So every time when you are not sure about dx or dy, please refer to your interval. Okay? Yang dalam match dengan yang dalam, yang luar match dengan yang luar. Okay? So can you continue to solve it? You will find that your answer equals to 2, but you can try to solve it in the area. Okay, now I want you to try example 2.3. Okay, example 2.3, page 52. Okay, so in this example, the A is you have to sketch the triangular region R with vertex -6, 4, 0, 0 and 2, 6, 2, 4. Okay, so you just draw the triangle. Okay, let's draw the triangle. Okay, draw your on the triangle. Okay. you have A, B, C. You can label their coordinate. Okay? Have you drawn your triangle? Okay, this is the only information we get from the questions. So look at B. Region R enclosed. Oh no, this is another question, is it? Okay, this is another question. Yes. Okay. For A, after we sketch it, we have to find the region of area of region R by using double integral. So it means now we have to find the area of this triangle. Okay, we have to find the area of this triangle. So what is the equations to find the area? You have to remember this one, dA. This is the general equation to find the area of any region. General. The key point is always on the interval. If you define the interval correctly, you can get your answer. Okay, here it will be always 1. This is the equation. Don't ask me why 1. This is the equation. Okay, now I want you to use the horizontal strip first technique. Okay, horizontal strip technique. Horizontal. Okay, this is your horizontal line. Have you drawn your horizontal line? Okay, now you can move down or move up your horizontal line. What will happen if you move down? What is 0? Y or X? Y. Okay? Y will be 0. Okay? If you move up, what will happen to your Y? 4. Okay? So you have defined the interval for your Y to be from 0 to 4. Okay? No problem, Next one. Imagine yourself is inside this horizontal strip, and when you look at your left side, what you will see? You will see a line. Am I right? Am I right? This is not a fixed value. Bukan 1, bukan 2, but is a equation. Do you know what is the equation of this line? Do you know? Can you find the equation of the line if the question didn't provide you? Yes. Can you try to find it now? Okay? Why I need to find? Because when I refer to the left, I see this line. But I don't have its equation. That's why I need to find. Okay? So can you find this thing? What you have to do? Find equation, Okay, so joining 0, 0 and negative 6, 4. 0, 0, negative 6, 4. Apa yang you kena buat? Y equals to mx plus c, right? So what is your c? 0. Intersection point on axis y is 0. So your c is 0. How about your m? Negative. Okay. Apa bahagia apa? This 6 is 4 divide 6, Am I right? Negative 2 over 3. Okay? And then you replace it. Y equals to negative 2 over 3 x. Because your C is 0. Okay? So I label my equation here. Y equals to negative 2 over 3 x. Okay, remember my question just now? If you refer to the left, you see this line, am I right? So what should be written here? Just now is y, right? So this one should be x. So what will happen to this one? Negative 3 over 2 y. Tahu kenapa tak? Tahu Ini pindah ke sini Okay? Boleh? Okay. We have complete the left hand side. What will happen if I move to the right hand side? I will see another line, am I right? Can you find the equation for this line? Okay, equations. Zero, 0 to 2, 4. Okay? So y equals to mx plus c again. Your c is 0. Your m is positive value. So it will be 4 over 2. You will have 2. Okay? So your equation will be y equals to 2x. Okay, so y equals to 2x. I put it here. Y equals to 2x. Okay, so just now when I refer to left, I get this one. So when I refer to right, I will get, yes, good, y over 2. Okay? You have got the interval, right? Can you proceed to find its area? What should be outside? What should be inside? So just now you have 0 to 4. So I assume all of you can put the interval correctly, Okay, you try to solve it. Okay, so this one will be y over 2. Just now I missed out something. When you are going to find the area, right? At the end, you have to put unit for the area. Okay, we don't know whether it is meter or cm or mm. We just put unit square. Represent the unit for the area. So can you get this answer? We are going to move on to the vertical strip technique. Vertical. So vertical strip. So I draw again my triangle. So just now I got this is equals to y equals to 2x. This is y equals to negative 2 over 3x. Okay, so are you ready for the vertical strip? Okay, vertical strip. So we move on to the vertical strip. Okay, so now you assume your side, you assume yourself is inside the vertical strip. Okay, what you will see when you refer down? You will see a line, am I right? So when you refer up, 4, right? So your interval for y will be from negative 2 over 3 to 4. Am I right? Y bukan X Will you confuse whether this is Y or X? Confused tak? Confused juga Okay, so when you refer up, this is a horizontal line, and this line has value y which is fixed equals to 4, but its value of x will keep on changing. That's why here you used to represent it with y instead of x. Sorry, this one. Okay. Have you ever think about what will happen if I construct another vertical strip at this region? When you refer down, what you will see? You will see your y 2x, right? When you refer up, 4. So which one I should choose? I have 2 different intervals for my y, am I right? So in this case, I have to split my triangle, big triangle, into 2 small triangles. Okay, meaning that I have to split it. Okay. Oh gosh. Okay, the first triangle is here. Okay. The second triangle is here. Okay, because both of them have different value of y. That's why I have to split it. I tak boleh macam tadi gabungkan semua. Okay, so for this case, what will happen to my x? I refer to this region. What will happen to my x value when I move to minimum point? I will have negative 6. When I move to the maximum point, 0. Okay, how about this one? Minimum is 0. Maximum is 2. Okay? So, for your area, you will have 2 sections. One section is for the triangle on the left side. Okay? And the other is for the triangle on the right side. Okay, so you have to define the interval. So this is number always outside. Okay? With variable always inside. So this thing again is dy, dx, and dy, dx. So now you have to solve two double integrals. Okay, can you try to solve it? So can you get the same answer? Okay, so you will get same answer no matter you use vertical or you use horizontal. But in this case, you will find that for vertical strip technique, it requires more steps. Am I right? You have to split into two sections. So whenever you want to perform the area calculation, please check which one will be easier. Okay? You can choose the easier steps. Okay? In this case, better if you choose the horizontal strip technique. Okay? I think you got an idea, right? How to use the vertical or horizontal in order to find the area. So now I want you to try in class. Actually, the same example, but I want you to try B. Okay? Question B: the region are enclosed by different line. Okay? Can you try it now? So I will prefer you to ask me question if you cannot. Please don't look at the solution in your module. Okay, try question B. Okay, that is same example. Example 2.3. Okay, page 52. Okay, B. Just now we try A. Now we try B. Okay. Don't look at the answer, try yourself first. Okay, so this is the simultaneous equations. This part, okay? If you want to find the intersection point between y equals to 2x, okay? And also y equals to negative x plus 6, okay? This point, okay? If you want to find this point, you have to list down the equation involved, okay? This equation and this equation, okay? Then, because here is y, here is also y, you put it together, okay? Then you find out what is x. After you get your x, you replace into one of the equation. Any of them, then you will give you the same answer. So this one is how you perform the simultaneous equation in order to find the intersection point between two lines. Okay, this one is also the same, but the equation involved is 1 over 2x and negative x plus 6. Dua ini. So you perform one more time and then you get another intersection point. So only after you get the intersection point, you know where to split your region. Region R1, region R2. Then you can define your x interval and y interval. Yeah, any questions?